Okay, so, we generating randomly, and I'm doing this for an assessment test that everybody's going to use, because this is something that wasn't originally on the assessment test, and it occurred to me, we really have to have a problem about, do these two quadratic functions, do their graphs intersect? And if so, where? Because that's a very important aspect of pre-calculus, and especially then when you go into calculus and have to find regions of intersection between two curves and integrate over that region and so forth. And then in this course, multivariable calculus, okay? So you really have to have a handle on that, so it's worth talking about right now anyhow. But this whole thing about randomly generating, and then do they intersect? Because, I have to choose my parameters. I randomly generate values of A, B, and C for each of two quadratic functions. And now I want to know, okay, well, it's going to pre-calculus students, dual enrollment on campus and everybody. I want to have some kind of a balance between the ones that have solutions, the ones that have a single solution, and the ones that have no solutions, okay? Now what I do is I generate each of these numbers, A1, the parameters, the ABC parameters for the two functions. I generate them in a fairly limited, but I generate numbers between 2 and 5, and they're negatives. So I have 8 choices for each number. Well, if there are 8 choices for each of these numbers, there are too many of these things to list and test. I could write a program to test them, to see if these things have an intersection, right? But you see, there are 8 choices for each of these, so they're 8 to the 6th. Okay? Well, 8 to the 6th is 2 to the 18th. Okay? And 2 to the 20th is a little over 1 million. Okay? So 2 to the 18th is 250,000. So there are 250,000 possible combinations here, possible pairs of functions. And I was going to do them in my head one night because I was having trouble sleeping, and as soon as I started, I just went to sleep to avoid having to do all 250,000 possibilities, right? Well, that's brute force. That's hit the gnat with a sledgehammer. There are more elegant ways to do this, okay? Well, we can't think this through. I could do a Monte Carlo simulation. I could do all kinds of things, okay, to get a handle on this. And I could just do, heuristic estimates and get a pretty good idea of what the probabilities are. But this becomes a really good question, first in probability theory, but it morphs into a multivariable calculus question that we have developed the techniques, turns into a three-dimensional graph, okay? So the question then is, well, let's reduce the set. Let's just go to the set 2, 3, okay? So all these numbers, all these coefficients, flip a coin, it's going to be a 2 or 3. Flip a coin, 2 or 3, depending on, heads 2, tails 3, right? So we generate 2 functions. What's the probability that the graphs of those 2 functions intersect? Okay? Now, it's still kind of a hard question because there's a distribution involved, and we don't want to deal with probability distributions too much. Okay? It takes us too far from what we can reasonably do in this course. So let's simplify the question just a little more. Let's just say, what's the probability that this first function, with these things chosen by coin flips between 2 and 3, okay? What's the probability that this function has at least one 0? That means you set it equal to 0 and have at least one solution, right? Okay? Well, and then, the next step, well, what if we expand the set to include plus or minus 2 and plus or minus 3, right? So now there are 4 possibilities. Well, with 4 possibilities, I think there's 64 possible, 4 to the third, 64 possible functions. You could actually write them down. You can go to your graphing calculator and have your graphing calculator graph all these things and see which ones cross the x-axis, right? Well, that's still gnat and sledgehammer, because clearly you can't do that if this set includes 2, 3, 4, 5, and the negatives, where you have 250,000 graphs to make. You could make 64 graphs, but we're really trying to get a handle on what happens, and then ultimately what happens if these things are chosen from the set of all real numbers, and we're going to do an exception of 0, because we don't want a to be 0. We don't want to get a linear function. Okay? Now there are other things we could do. We could choose a not to be 0 and then choose b and c, right? Or we could choose a equal 1 and then just choose the b's and c's. Okay? There are all kinds of things we can do to change the parameters of the problem, but the analysis is still going to be the same. Okay? So the question is, if we choose from this, how do you determine if a quadratic function has a 0? Well, it's very simple. I'm going to just show them. I don't want to go up there. But have to write a little. This is ridiculous. My shoulder's been great. I don't know what I did. Probably why I slept on it. Okay. It should loosen up. Okay, so y1 has a 0 and possibly more, right? Because it has 2 zeros, it certainly has a 0, and that's really all we need to know, right? And this is something that y'all should have, you should know the quadratic formula, and it turns out that you're a little fuzzy on it. By the time you get to multivariable calculus, if you haven't used the quadratic formula so many times that you couldn't forget it if you tried, probably haven't done enough problems, and that's probably because you haven't been assigned enough problems. Anyhow, y1 has a 0 provided what? That b1 squared minus 4a1c1 is greater than or equal to 0. That's it.
We know that's
So you don't have to graph everyone, which is a good thing if you got 250,000 or more, or infinite number, okay? You just have to deal with this, right? Well, that's a simple inequality in 3 variables, right? So that's equivalent to saying, let's just say z squared minus 4xy greater than or equal to 0. And now we're into the realm of multivariable calculus. Okay? We can graph this function, or at least we can graph z squared equals 4xy. That graph is the boundary between where this thing is greater than 0 and where it's less than 0. Okay? So this is the boundary between the regions of three-dimensional space, right? Where this is greater than 0 and where it's less than 0. Okay? So, how are you going to graph this?